Uh, Good evening, one and all. Today it's the 11th live session for the course Basic Environmental Engineering, Pollution and Abatement. Uh, so far we have been discussing on how uh, pollution is generated, how it affects the human beings and their lifestyles, and what are its adverse impacts. So in that case, how the pollution is generated, what are the contaminants present? So that all we have seen so far. So moving forward, we had seen how we can control the pollution emission so that we can have a minimized impact on the environment as well as on human health and other living organisms. And we have also seen specific industries that result into, the what could be the pollutants present in the effluent from specific industries. So case studies we have also seen. Now moving forward, we will be looking into the um, solid waste, right? We will be looking into what could be the solid waste that we can have and what are the ways of dealing with solid waste, right? So I have shared my screen. Just give me a moment. Yeah, so I hope you are able to see my screen. Um, yeah, so now let's start. Okay, so let's see. Uh, Firstly, what are the types of solid waste? So far we have seen gaseous pollutants and air pollution because of these gaseous pollutants. Then pollution in liquid stream or water. And now we will be looking into uh, solid waste, right? So what are its sources? What are its types? And how do we deal with these solid waste? Okay. So first, let's classify solid waste and what is its meaning. So solid waste is nothing but any waste which is in solid form. Now it can be classified in various types depending on various methods like or various types. It can be classified based on, for example, what is its source. Now solid waste can be generated from domestic or household. So here domestic and municipal waste are nothing but any solid waste which we throw in dustbin and that are because of household and um, household usage, right? Or any commercial usage, so domestic and municipal waste. Then we have industrial solid waste. Now, it is not necessary that solid waste is always from the sludge of wastewater treatment, but there are reactions also going on which generates solid byproducts as well. So, these can also be considered in solid waste. And lastly, if you have agricultural waste, for example, if you have plants that are grown, so now or any crops that are grown. So there are chances that you do cutting, trimming of the plants, crops. So all such sort of waste which will be coming from that plants and crops. This is just one example. So that is an example of agricultural waste. Now, depending on the biodegradability, it can be classified into biodegradable and non-biodegradable. So, why are we classifying these this solid waste? Because if we know what is its nature, then either we can so we will be able to get to know whether we need to dispose it off or if we can recycle and reuse that waste. So depending on its category, we can see what will be its final like where will it end up, right? Whether we can recycle, reuse, or whether it needs to be disposed of, right? So now if the waste is degradable in nature, then we can have a composting out of it, while some non-biodegradable waste, they can end up in landfill sites, or we can recycle also non-biodegradable waste. Now, next is combustibility. Okay, so now if your solid waste is combustible in nature, what we can do is we can combust it so that we can minimize its volume. Also, this solid waste might have calorific values. So, higher the calorific value. So, calorific value is nothing but of solid waste. It is nothing but how much amount of heat is produced upon combustion, right? So, if you combust that, if it is able to uh, do combustion of the solid waste, we can extract heat from it. Also, we can minimize the volume of solid. And yeah, obviously, based on the combustibility, we can find out whether we can have such usage or not. Another way is compostability, whether we can convert it into compost or not, so that we can use it as uh, a fertilizer, right, or not. And its usability, whether we can recycle it or whether it has inerts. So inerts, if we are able to extract those inerts, what are the types of inerts and where we can utilize it. For example, inert is in the form of sand or rocks. So we can have some sort of, if there is a building construction, there are road constructions. So these type of inerts can be sent for reuse in uh, buildings, for making buildings, roads, etc. Right? So these are all, based on different types, different usage, and their characteristics. We have classified solid waste. Now, what are the sources? So, from the domestic uh, usage, majorly the solid waste, they are majorly biodegradable in nature. That includes food waste, okay, tea trimmings, right? Okay, so we have a garden in our home, let's say, and we want the plants to be properly it should be aesthetically pleasing. So we try to have a proper shape or proper cutting of the plants also. So the residue from it is nothing but tree trimming, which is also a waste, and obviously it is biodegradable. So next is another type of waste which we can recycle, right? So that is paper, plastics, glass, right? So And also the inerts, including stone, sand, silts. Okay. So, to have proper uh, segregation or proper recycle and reuse of each of this waste, for example, biodegradable waste, including food and tree trimmings, they can be sent, they are compostable in nature. Okay, so they can be sent for manure production. While this can be reused, okay, for example, paper, plastic, etc. So in that case, what you can do, like government has made provision to have, uh, like whenever in any building at your homes as well, there will be different types of dustbins for dry waste and for wet waste. Okay, so in that case, you are able to, uh, it will be easier for you to separate these waste and later you can make it, uh, uh, later you can reuse or recycle the waste, right? Next is agricultural waste. Um, these are nothing but any lignocellulosic agricultural residue. Okay. Now, if we want to have solid management or if we want to minimize the solid waste generation and we want to have a sustainable way of reusing it, so in that case, firstly, the first step involves in this process is waste generation and collection. So from the generation point, you are collecting the waste. Now, as I mentioned that depending on the characteristics and the properties of waste, it can have different end point, like whether it is to be disposed of, whether it is to be combusted. So depending on that end use, we need to have separation. Okay, so for combustion, because we cannot mix the waste which is combustible in nature with the ones which is compostable, right? So we need to segregate all types of waste, so that it is easier for us to recycle and reuse or dispose it of. So segregation at source and transformation at site, it is an important step so that it is easier for the further processing of the solid, right? So, as I have given you the example of multiple dustbins at our home and any hospital or any academic building, so it will help in segregation of the waste. So, it is an example of solid solid management where segregation you are doing of the waste. Now, last, if we want to dispose, once we have done all the processing of these solid and whatever the end product remains, that needs to be disposed of. So disposal can be in multiple ways. For example, open dumping, you are just throwing it at any place. That is open dumping, which is not at all advisable. Next is landfilling. Now, landfilling is a proper method of disposing of waste, right? So, what you are doing for landfilling, you are digging out the soil, okay? And by digging out the soil, you are generating a space where you can dispose the solid, right? Let me show you. Okay, so let's say this is the surface. So, you now dig out the soil and similar uh, surface is created. Okay, so now you dump the waste into this site every day. So let's say solids are dumped here. So after certain layer of thickness, you further pour the soil. Okay, so this is waste. Now there will be again a small layer of soil which will be there, so that there is like not much, like there is still you can have some value out of it. Now you do this still. it is completely covered. Okay, you completely fill this, and last portion will be a thick layer of soil, which is having good nutrient value. So this will be soil with good nutrient value, so that you can have trees and plants and some garden that can be grown, so that it is aesthetically pleasing. Now there are chances that some water percolates in this landfill site. There are gases which are generated from the solid waste because of, for example, there are microbes present, so it can have anaerobic digestion. So leachate, which is a liquid uh, formed after certain time uh, from the solid. So this can be toxic in nature. So that leachate collection provision is also provided in landfill site, and gas collection provision is also provided in the landfill sites. Then another method, so this is one of the most explored, right? Then another could be disposal in the solid surface, barging into the sea. So these are now not used. Okay, so you do not want the sea to be further polluted. So these are all not used nowadays. Now, so for recyclable waste, which are non-combustible in nature, this includes glass, metal, okay? So that can be recovered from the solid waste, and you can uh, reuse it, and you can recycle it in other form as well. And you can have some combustible waste in the form of plastic and paper, so that you can extract energy out of it, right? Next is organic waste. So it can be given biological treatment, and we can have a composting so that we can synthesize fertilizer or manure, and you can have a biogas plant so that you can generate fertilizer and manure along with CH4, which is the fuel, right? So these are the ways you can have a uh, sustainability, so that out of waste also you are trying to recover as much uh, in the form of energy, in the form of some byproducts. So as much you can recover, you are trying to recover out of it. So then there are inert debris. So you can have a low grade construction. As I mentioned, you can have it's used in road construction, buildings, etc. Right? Then you can have hazardous waste. Okay, so in the case of hazardous, it could be from hospitals, right? So, uh, for example, it has some biological contamination. So in that case, uh, it is not advisable for a landfill disposal directly, because it can have spread disease, right? So it is advisable for incineration. We will discuss what incineration is, right? So basically, we are destroying that waste. So for hazardous, it is advisable to have destroy this if we are able to destroy that waste, so that, for example, if the waste is coming from hospital, it can have blood, it can have um, organs, or any such biological products, byproducts, so that can further spread disease. So in that case, it is advisable to destroy it, right? So is it clear so far? Okay, so now if we want to use uh, or dispose the waste in the landfill sites, there could be different classes of landfill sites as well. Because solid waste, it need not to be having same characteristics and same toxicity. Okay, so it is not advisable to mix the final solid which is to be disposed depend if they have different toxicity. Okay, so for hazardous waste after incineration, or if, for example, hazardous waste could be also of different types. One which can be incinerated or that is combustible, right? While others cannot be, right? For example, if there are metals, we cannot send it to incineration. So this needs to be directly disposed of. So hazardous waste it is not advisable to mix it with other waste. So should be uh, it should be sent or to a landfill site separately. So there should be a separate landfill site for this type of waste. Next is for incinerator waste or sewage waste sludge. Okay, because that has lower toxicity as compared to hazardous waste, right? And they have completely different characteristics as compared to hazardous waste. So in that case, it is uh, better to separate these waste and have different landfill sites. And lastly, for sanitary landfills. Now, here we are talking about hazardous waste. So, what are hazardous waste and how do we get to know, or what waste do we classify them as hazardous? So, any waste which has corrosive properties, for example, corrosiveness is nothing but it can cause rusting, okay? It can damage the surface if it comes in contact. It can be a wooden surface, it can be some alloy surface, iron surface, etc. It is ignitable. It causes some reaction, okay, and it causes some adverse health impacts, which is nothing but toxic, okay, adverse health impacts, right? So all these type of waste are nothing but hazardous waste. Now, another type of solid waste which is creating problem nowadays is plastics, right? Because they are one of the most generated waste which is non-biodegradable in nature. Okay, and nowadays people are highly using plastic, and everything contains plastic. Like plastic is there everywhere, because of which you would have heard of, microplastics also, which is causing toxicity. Let me show you the example of it. Yeah, so yeah, so microplastics are nothing but they are the plastics which are uh, you know, if we are having a cup of tea and it is in the, we are drinking it in a disposable cup. So that disposable cup is having a layer of plastic, so plastic on it. So that uh, warm tea, it has the tendency to dissolve certain plastic at a very micro level, and it forms plastic which is nothing but known as microplastics. So people like nowadays, even we are from our bodies as well, few amounts of microplastics are formed, which has caused high toxicity, right? So, it is advisable to have a proper management of this non-biodegradable plastic. Okay. So, first and foremost way of managing this plastic is to refuse its use. For example, if you are drinking a tea, or if you are getting some food delivered, or you are taking food from a restaurant to your home, it is advisable to you not to use plastic container which is provided by the restaurants. You take a vessel which is um, made up of steel, right, from your home itself, and you can uh, take the food from that uh, restaurant in that steel utensil. So you're refusing the use of plastic. Okay, so first and foremost way is refuse its use so that it is not at all generated as a waste. Another example could be if you are going to a market to purchase something. So it is always advisable to use paper bags or cloth bags, bags for uh, carrying the material and stuffs, so that plastics are not used as the uh, material to carry your stuffs. Then reduce its consumption. So if you are not, there are chances that it is unavoidable to use the plastic. So in that case, it is always advisable to minimize its usage. So try to use it as minimum as much as possible. Okay. Next is reuse that waste material. For example, if you have a polythene bag which you have obtained while carrying some stuff, so instead of just throwing that polythene bag, you can have some another usage while you are going outside. Okay, so you are trying to reuse that polythene bag as much as possible. Then repurpose it. Okay, so once you have used, and now what you are doing, you are trying to recover the waste and reuse the waste without any pre-treatment. So, but not for the same purpose. Okay, so you are using it, but not for the same application. So that is repurposing. And at the end, if that plastic does not have any value, so you are recycling it by having some further processing of the waste and converting it into the another product so that you can further recycle and reuse it, right? So these are the strategies to minimize the waste. Now next is the treatments that are provided for any solid waste before it is disposed of, and majorly these are given for the organic waste. Okay, so first and foremost treatment which is given to uh, uh, the waste is incineration. Now, incineration is nothing but combustion of organics which is present in the waste material, right? And here you are combusting the organics, which means you are supplying, it requires air supply, right? And so organics, they are combusted, so the end product will be CO2, H2O. If there are sulfur, nitrogen contents, so SOx, NOx, etc. Right? And the major reaction is combustion. So combustion reactions are always exothermic reaction. So it generates heat. So whatever the gaseous products that are formed, it has um, very much high temperature. Okay. So the products out of it is nothing but some of the ash content, which is nothing but a carbon product, which is not further combustible, and the gases Gases which are nothing but carbon dioxide, water vapor, SOx, NOx, which is the combustion byproduct or combustion product after the combustion of organics. So the steps involved here is first, uh, let's say you have a solid waste product. Now there are chances that there is moisture content which is present in that solid waste. So obviously, first and foremost thing is the drying of that solid waste, and there are high chances that there are some volatile components also present in it. So that are also removed. So firstly, drying happens and volatile components also escape. Then minor pyrolysis might happen, and major step is combustion, right? Which happens at more than 900 degrees centigrade, right? So this much high temperatures are operated, and at such a high temperature, the combustion reaction occurs, and you know, you are converting the high voluminous solid waste, which might be toxic, to carbon dioxide and some another SOx, NOx. Okay, so yeah, this is the process. Now, the air that is usually provided, it could be some excess. Okay, so 5 to 50% depending on the type of waste. You can provide it in excess. So, lab scale calculation is always done. What is the theoretical air requirement? And you always provide some amount of air in excess so that complete combustion is ensured. Okay, otherwise, if uh, in real scenario, it is not always necessary that complete combustion and the 100% yield is obtained. So, by ensuring excess air, you are ensuring complete combustion. Now, during this process, what are the main parameters that affect the performance? Okay, so let's say this is the incineration chamber. So this is the reactor where incineration occurs. So the factors affecting include what are the feed components, right? Then what time is provided for the combustion to occur. More the time, more you are ensuring that complete combustion has taken place. Then the temperature that you are providing. Okay, so depending on the feed components, some temperature is required so that the complete combustion is occurring. So in that case, what the temperature is prevailing in the reactor, it determines the performance of that incineration process. Further, the turbulence or the degree of mixing provided. Okay, so more the homogeneous uh, mixing you are providing, more will be the uh, chances of reaction going on, right? So the process flow sheet or the complete process involves first the sorting. Okay, so if you have uh, you are sorting depending on the size and all, then you are homogenization where the different types of waste also might be there. So you are mixing all the types of waste so that a homogeneous mixture is present, right? And if it has high or bulk sized or very coarse, so for higher or more sized solid waste, so you are shredding it. Okay, so you are cutting it down so that the process is more efficient. And then it is sent to incinerator where the conversion takes place. Now, as I mentioned, that incineration is a very high temperature process, above 900 degrees Celsius. Further, the process is also exothermic. So the gases which are formed very high temperature. Okay, so that the gases that are formed, they have very high temperatures. So instead of sending directly to the storage or final, for example, final destination, so it is better to recover that heat so that uh, you can either send you can recover that heat for steam generation. Um, you can send it to boilers. So or you can have you can send it to uh, heat exchangers because any industry has multiple heat exchangers where you are exchanging either cooling or heating the process. Okay, so if you are taking out the heat, you can send it to the reactors which require heat to in the form of heat exchangers.
Hello,
You
ma'am.
can send it to boilers to generate
Yes.
steam. Yeah,
I wanted to ask that the size of these incinerators, is it very large or what is the size? Because see, a lot of energy that you, I mean, might be get wasted or is used. Like, what is the amount of that? Do you have any numbers or something like capacity of that energy, and what is the size of this incinerator? Is it huge? Is it like 1 feet, 2 feet, or 100 feet, something like that? I do not know.
the 100 feet is too big, but it always depends on like it's a column basically which may be few feet, right? Uh, I do not have the exact number, but it could be a few feet, and yeah, and obviously its size depends on the amount of solid waste that you need to handle, right? So obviously you cannot have very tall column because it further needs some support. You cannot have uh, if you have very large amount of solid waste to be handled, you cannot have very tall column because there will be some wind pressure also existing at a height. So it is always better to optimize depending on the site. So there is not a specific number, but it depends on various factors, but it is always few feet of height. Like not obviously of our height, it would be bigger than that, maybe 20 feet or so, 10, 20 feet. But it depends on the region, it depends on the scale of waste management and the existing um, environmental condition because as you go up at higher altitudes, there are higher wind pressures existing. So more increasing the height, it will exert more pressure and you need better supports in that case. So that also you need to take into consideration. So all those factors they affect the size and the height of that incinerator.
Thank you, ma'am.
Okay. Yeah. So next is what type of the reactor design you need to have for maximum uh, conversion. So there could be some different types of reactors. For example, you can have fixed bed reactor incinerator. Then you can have rotary kiln or you can have fluidized bed. So these are nothing but different modes of operation. So fixed bed is nothing but you have a flow of solid or you have uh, a bed of waste through which you are passing air from bottom or you can have a cross flow also. So depending on the orientation, uh, co-current flow is always the best operation. So there will be a bed of waste. through which air is circulated and combustion takes place, right? So air passes through the fixed bed where all the processes takes place, right? So you have a bed and air is passed through it, and so it is a easier operation and easier to operate, and you have good conversion as well in this type of reactors. Then you have rotary kiln type reactor where there is a cylindrical shell and you are passing the feed in this direction and air passes in this direction. So there is a co-current operation taking place. Not sorry, not co-current, counter-current. Counter-current is always the best type of mode where you should operate. So cylindrical steel shell where counter-currently waste and air are contacted. So in this shell, they both are contacted counter-currently, and uh, the cylinder is always rotated. Okay, so this would be the direction axis of rotation, so that there is this rotation provides a turbulence for the feed to rotate, and this ensures a complete mixing and mixing of feed and air, so that complete and higher conversion is ensured. And next is fluidized bed. So fluidized bed, what it has, you pass the air from bottom or from the sides. So this could be the direction of airflow, and you are providing feed from the top, and air which is passing in the upward direction. It ensures that the feed which is coming from the top, it is um, moving as if it is a fluid in the uh, reactor. Okay, so it will not allow. So you are passing air at a very high velocity, so that it is not allowing the solids to settle down. It is keeping the solid waste in the air itself, like it is in the air, right? So its settling velocity here is zero, and it remains here. Okay, so settling velocity and the top velocity both become zero here. So net velocity will be zero, and it will stay intact here, floating, which behaves as if it is a fluid, right? So for this, if the particle size or the size of solid waste is much high, then obviously it will settle down. We require much high air velocity, or any air velocity will not be able to make it float. So the size of waste should be small, like obviously not in nanometer, but few micron or millimeter sized waste particles can be working in this case, but higher size will not be suitable. In that case, it is better to have fixed bed columns, right? Finally, you can have whatever the gaseous products that are formed, CO2, NOx, SOx, then that flue gas cleanup is also required, so that whatever we are producing, it is not directly ending up into the atmosphere, where it undergoes nitrogen oxide cleanup, mercury dioxide removal, any sort of acid gas removal, for example, SOx removal, and the removal of particulate matter if it is present, because obviously with air and the flue gas, there will be some solid dust and ash material which will be taken up by that flue gas. So that also needs to be separated, right? Now next is what type of another process we can provide is gasification. Now all these processes are nothing but dealing with uh, organic feeds, waste products. But here, what you are doing is you are having different amount of oxygen or air supply. So in the case of incineration, you were ensuring that there is excess of air so that there is complete combustion, right? But in the case of gasification, so if you say CO2 is also, a pollutant, it causes global warming. So in a way, you are converting one waste to another waste. So to avoid that, you can have gasification process, right? So gasification involves partial supply of oxygen, which is okay. So you are combusting the material waste, but in the presence of oxygen, which is lesser than theoretically required amounts, right? So by this process, what happens is whatever the uh, organic compound is present in the presence of limited supply of oxygen. So here the limiting reagent is oxygen. So limiting reagent. So oxygen supply is limited. So in that case, the major product that will be formed will be CO and H2, right? So CO is uh, carbon monoxide and CO and H2 combinedly it is known as syngas. Now this syngas is a reagent to many um, products or liquid fuels also, right? So in that case, what you are doing, you are making the process sustainable by converting the waste into a reagent, which is like into a product or into a component, which is reagent to n number of useful products, right? So syngas is a reagent to many products, many useful products. So what you are doing, you are converting organics into syngas. Now, if pure oxygen is used for combustion, then syngas will be formed, which will be majorly CO plus H2. Now, in the case if you are using air, then N2 will also be present, which causes the producer gas to be formed, right? So, product mainly involves CO. There could be some complete combustion also taking place. So, some amount of CO2 will also be present, and some side reaction also takes place, which causes CH4 also to be present, right? So, is it clear so far? Okay. So, yeah, the again the steps involved here in this case would be uh, firstly removal of the moisture which is present by drying the solid waste, then devolatilization, oxidation, and you are extracting because of the high temperatures, uh, the reaction going on, whatever the ash and the final flue gas that is formed or the syngas formed, they have high temperature. So you are extracting the heat. Okay, so again, the factors that affect gasification process involves type of feed injection by counter current or cross current or the reactor basically, which defines the feed injection type, the gasification reagent, the air or oxygen that you are using, the type of heating where you can have direct or indirect heating, the temperature at which you are operating. Uh, can you please give me a moment? I will just be back. Yeah, अंगीरा नहीं है सर को पता है मैं सर को बोल दो कि सर यू कैन लॉग मतलब ऐसा ना लगे कि कोई है नहीं सबको बोल दो ना कि मैं 120 क्या क्या मेरा बोल दो कि मैं 120। Um, Sorry. Let's start again. Yeah. So we were talking about the process flow sheet. So basically, the waste that goes into whatever the pre-treatment might be needed, you provide the pre-treatment, and it goes to the gasifier. Now, the main product here is the syngas, and there could be some ash formation or final solid formation, which will not end up into further combustion. So solid residue, right? So there are two phases formed. So gas obviously is obtained from the top and solid is collected at the bottom, right? So that syngas also might have some ash particles and some feed material as well. So you need to have a cleanup of that syngas, and whatever the solid residue and the unrequired components are there, they are further recycled back on the into the gasifier, so that you can either, if it is waste, unconverted waste, you can provide conversion, or if it is ash, you can collect it later, right? And after the syngas cleanup, another step could be removal of stalks also if it is formed. Um, and then you can send the syngas for generation of any liquid fuels, right? Chemicals. You can send it for separation to form H2, which is a fuel basically, like clean fuel, because if you are using H2 to generate energy, it forms H2O. So it is a clean fuel, you can say. And or you can send the syngas for steam generation and power generation, right, over the turbine. Uh, yeah, and yeah, this ash needs to be disposed of. Now, similar to the incinerators that we had used, for example, fluidized bed, fixed bed incinerators. Similar type of gasifiers we can also use. For instance, we can have fixed bed, we can have fluidized bed, entrained bed, and plasma gasifier. Uh, okay, so fluidized and fixed bed are similar to the previous case. Just the difference is the amount of air or oxygen which you are providing. So here you are just providing lesser amounts of air and oxygen, so that the reaction that is taking place will be different. Otherwise, the mode of operation is completely the same as incinerator. which we had discussed in the earlier slide. So, next is the entrained bed, where you have the flow of both, uh, you know, uh, waste as well as oxygen from top, right? So you can say the waste is uh, there is a complete mixture you are providing, and the waste is entrained into the gaseous phase, which travels in the bottom, and the conversion takes place. And lastly, another is plasma gasifier, where you are providing plasma as the source of heat. And what plasma does? Uh, Plasma is nothing but a state of matter which has radicals and ions present in it. So it generates further, uh, or it causes, by providing plasma, you are giving energy for uh, partial combustion of uh, the feed waste to produce uh, syngas. Okay, okay. So this was about the gasification process. And last process is nothing but uh, the process, where you are not at all providing any air supply or whatever the decomposition occurs. It is thermal in in the presence of heat, but in the absence of oxygen. Okay, so here also by limiting or by not providing oxygen, you are converting the organic waste into some products, which is bio oil. It could be biodiesel, it could be some uh, uh, LPG, and so on. Water and gases like CO, CO2, CH4, and H2, because there could be in the organics also there could be some oxygen content which results into CO and CO2 formation. Otherwise, CH4 is the main product, which is again a biogas which acts as fuel, right? So there are two different types of fuels also formed by this process, and char is formed, which also has some end product, right? So, end application. So, which we will see what is the end application of that char, right? So, there are two types of decomposition steps. First is the primary phase decomposition, where gases and char is formed, and another is secondary phase where cracking happens, right? And similar to previous cases, obviously, the temperature, because it is a thermal decomposition, whatever the temperature prevails, it determines the products formed, the yield and conversion of the process, the residence time, heating rate, and the feed size. Okay, all these factors, they affect the process. For example, if you are having a faster rate of heating, then you can have immediate conversion. So, faster rate of heating indirectly affects the rate. Okay, so uh, depending on the type of reactant, there could be some different reaction kinetics. So, that is why heating rate also affects the process. Uh, Yeah, so if we talk about the liquid product, then bio oil is the major liquid product out of the pyrolysis process, which is a type of biodiesel, you can say. Now, if you want to use this as a fuel, then there the physical properties it has. If we compare it with diesel that is generated from crude oil, then this bio oil has higher viscosity, lower calorific value, and high oxygen content. So this higher viscosity and high oxygen content, they further reduce the calorific value. So to upgrade the bio oil properties, for instance, if you want to reduce the viscosity, reduce the oxygen content, you can provide some upgradation through physical and chemical modifications, including filtration, emulsification, and chemical methods include reaction with alcohols, okay, and some catalytic deoxygenation. Okay, so by providing catalyst, it results into some specific reaction taking place because catalysts are very specific in nature, right? So, yeah, by that method, you can upgrade or increase the properties of the bio oil that is formed. Now, the reactors that could be used are similar to previous, which is nothing but fixed bed, fluidized bed, rotating cone, ablative reactor, etc. Now, out of all the products that are formed, the char that is formed is um also used in some manner. For example, it can be used as solid fuel if it has good amount of calorific value. Now, this always depends on what is the properties of that char. Then soil conditioning, if it has some amount of nutrients, it can be used as fertilizer, okay, if it has some nutrients. Otherwise, you can use that biochar for activated carbon production, uh, right, by providing some physical and chemical treatment to the char and always as an adsorbent to absorb organic contents present in water, okay, or as an adsorbent for absorbing gaseous pollutants. And if we talk about the gaseous products that are formed, then that gaseous product also has some high temperature. So that can be used to recover the heat. Okay, and it can further provide the heat to the pyrolysis product. Uh, syngas, you can use the hydrogen for hydrogenation process for manual upgradation, or you can further use H2 for electricity generation as a heat. So all these are nothing but uh, the usage of, uh, of the products that are formed from pyrolysis and pyrolysis. Okay, so if I summarize all these processes, incineration majorly generates CO2 by complete combustion. So instead of using incineration, um, it is advisable if for organic contaminants that are present in the waste. It is advisable to remove composition then go for incineration or you can go for pyrolysis because you are end products which are usable and this is how you make the process sustainable. Otherwise, incineration forms CO2 which might pollute further or in case if you have some hazardous waste, then you can, for example, from hospital, you can send it incinerate, right? Because you need to destroy it completely. So in that case, you can have incineration. Now let's move for the assignment. So the first question is which of the following is not considered as a biodegradable waste? So biodegradable here is the term, which means that it should be degraded by micro organization. So by micro it should be degraded. So foodstuffs, plants, plus animal waste, they are all organics. Next is solvent extraction. As I mentioned, we are adding another solvent which results into separation and anaerobic digestion, where you are decreasing organics and so you are not adding the correct answer is incineration. Next is depending on the fuel properties and system configuration, the temperature excess air required for various combustion system is in the range of dash. So typical this is a say 5 to 50% of excess air is usually provided for combustion. Right? So correct answer is 5 to 50%. Next is identify the type of incinerator. So look at the options because this is where we will spread and complete. So please guess the expert. Now, vertical is the one which requires a cylindrical shape, which countercurrently the heat and the gas they are passed. Okay, so this is the rotary kiln type of reactor. Next is Fischer-Tropsch synthesis is normally used to convert syngas into the liquid fuel. So you are converting the syngas into some fuels, which is nothing but the reaction is uh, known as Fischer-Tropsch. This is next question is the gasification process where air is used in place of oxygen to produce clean gas contains high amount of gas. So mainly for gasification, the main product is CO plus H2. Now N2 if you are adding, it always acts as an ethanol. Okay, so N2 is always as an ethanol. So instead of if you are giving oxygen as the source of combustion, then CO and H2 will be. However, if you are adding air, because it does not have a heat, the oxygen is pure. However, if you are adding air, then air has O2, N2, and other trace of gases, right? So along with this combustion taking place, into which acts as the will also be. So nitrogen is also formed during gasification if we are adding air of combustion, right? So here N2 is the correct answer. Next question is which of the following is the chemical method used for the oxidation of hydrolysis by the fire? So if you look into the options, here the key process chemical might be solid addition, filtration, emulsification. These are also the process but require physical method are nothing but it involves some reaction. So hydrolysis is nothing but reaction with hydrogen and either convert some into some another form so that it reduce the viscosity. However, solid addition, filtration, emulsification. So these are nothing but some physical forms. They are not having some uh, chemical conversion. Okay, so chemical conversion is only involved in hydrogen, which is the correct answer. Next is identify A and B in the following process. So if you look at the OG, OG, then see the The flow sheet itself says which what is the process. Okay. Uh, See, this is the hydrolysis. So in that case, say, and the products that are formed are nothing but these are all fuels, liquid fuels, and the char. Okay. So you can see all these indicates that the process taking place is the pyrolysis process. So the major reactor will be pyrolyzer. So in here is nothing but pyrolyzer. So now the products that are formed, it is sent to a separation chamber where you are separating liquids and gases, right? So further if you are seeing, then liquids are also fragmented into different products depending on their volume. Okay, so gasoline, which is petrol, kerosene, and diesel, they have different volume points and they are separated. Okay, so this kind of separation takes place in distillation point. Okay, so A is pyrolyzer and D is where you are separating liquids based on boiling point separation based on their boiling points. So D is nothing but distillation process. Next is in a fixed band where gasifier air air flow rate uh, and feed flow rate are 50 and 12 respectively. Units are given. Now the feed material does not contain sulfur, nitrogen, chloride because these, if they are present, they can result into some side reaction like consumption of oxygen. So these side reactions are safe and they are eliminated. So the synthesis majorly contains CO, which is 40%, CO2, which is 2%, H2 30%, CH4 5%, and C2H2 2%. So you are asked to find out the rate of production of syngas in this unit of the per kg of the feedstock. Right, so to find out that, there is a well-defined formula which is shown to you in the class. Okay, so for fuel gas production per kg of feedstock, you need to use this formula. It says that air flow rate, which is directly given to you, 50 into 0.79 divided by 1 minus. This has nothing but the fractions. Okay, so CO fraction is 40%. Okay, you are dividing it by 100, so you need to use 40%. You need to keep your percentages into the feed rate. Okay, so you add everything here into the feed rate. Feed rate is nothing but 12 kg percent. Okay, so solve this. So solve this. So should give you answer as 7. So much of gases. From my side, okay.